Here is the second type of conic section. This is going to be parabolas. So we've seen parabolas with quadratic equations, and now we're going to see it in a more geometric sense. So the definition of a parabola is the following. It's just all points in a plane that are the same distance from a point, and this point is what we call the focus, and a fixed line. And this fixed line is what we call the directrix. Now, you don't really need to know a lot about the focus and the directrix unless you're going to go take pre-calculus. In pre-calculus, you heavily talk about the focus and the directrix. But geometrically, basically, this is what's going on. You have this parabola, and you have this point. And this point is what we call the focus. And then you also have this other line, which is called the directrix. And what this means is that if I pick a point here, let's say here, this distance from this point, the focus, to this point, this distance d, is the same distance as this from here to the directrix. Now, it doesn't quite look like it because my picture is pretty much off, but that's basically all it is. And what you're going to find out is that you actually have parabolas that kind of look like this too, where you have a focus and you also have a directrix, and the same thing happens. So you're going to see both vertical and horizontal parabolas. Now, what we're going to do now is we're not going to focus a lot on the focus and the directrix. We're going to more focus about what's going on with the parabolas. Now, what I want you to take a look at, and maybe pause the video, is take a picture or write this down for vertical parabolas. So take a moment to just pause it, and I'm going to explain what all of this means. So basically, we found that you have two different types of parabolas. So you have parabolas that have this general form y equals ax squared plus bx plus c, and you have the standard form, which is kind of like in vertex form, I guess. Remember the parabola, vertical parabola, the orientation, if the a value is greater than 0, it's going up. Same thing with the standard form, that doesn't change. If it's less than 0, it's going down. Okay, so basically, if a is greater than 0, it's going to be a happy parabola, so a is greater than 0. If it's less than 0, it's going to be a sad parabola. And it happens for both. If you want to find the axis of symmetry, remember the axis of symmetry is that line that kind of divides a parabola in half, and that makes it a mirror image. To find the axis of symmetry for the general form, so if you have something that looks like this, just use this formula, x equals negative b over 2a. Standard form, all it is just x equals h. That's it. Vertex, x equals negative b over 2a, and then plug it in to find y. For the standard form, it's just going to be h and k. So very easy. Y-intercept, set the x equal to 0. X-intercept, set the y equal to 0, and then just solve. So those are things that we've done before, and it kind of seems really silly just doing it again, but I think that we really need to review the graphing portion and all of these things again. So if you ever want to graph a parabola, just follow these directions. Literally go by orientation, axis of symmetry, vertex, y-intercept, and x-intercepts. Okay, so let's do a couple of problems. So here's going to be my first problem. So we want a graph. And my graph is going to be graph y equals negative x squared plus 6x minus 8. That is the first problem that I want to solve. The first thing that we do is find the orientation. So that's the first thing. So orientation. Now the orientation is going to be the value of a. It has the form in general form. So we're going to look at this column. This is the column that we're going to look at. So a is greater than 0 goes up. A is less than 0 is down. In this case, a is negative 1. So it's going to go down. So the parabola is going to go down. So it's going to be a sad parabola. That's the orientation. Okay, the second one is the axis of symmetry. That you can figure out by x equals negative b over 2a. So x equals negative b over 2a. So negative b in this case is going to be the 6 over 2 times a, which is negative 1. gives me negative 6 over negative 2, which gives me 3. So the axis of symmetry, where it divides it, is at x equals 3. Okay? The next thing that we want to look at is the vertex. So number 3. We just figured out x equals negative b over 2a, which is equal to 3. Now we want to figure out what y is. Well, y is going to be negative x squared plus 6x minus 8. I'm going to plug in this 3. It's going to be negative 3 squared plus 6 times 3 minus 8. This is going to give me negative 9 plus 18 minus 8. Putting this on my calculator, I get 1. So my vertex is going to be 3, 1. Okay, so now I have my vertex. The next thing is to find the y-intercept. So it's going to be 4, the y-intercept. And in order for me to find the y-intercept, I said x equal to 0. Okay, so I have y is equal to negative x squared plus 6x minus 8. Set x equal to 0. Negative 0 squared plus 6 times 0 minus 8. This goes away, so y equals 8. So my answer is going to be 0, 8. This is my y-intercept. And now finally, just find the x-intercepts. My x-intercept is literally by setting it equal to 0. Y. So it's going to be 0 equals negative x squared plus 6x minus 8. One thing that you can do is use the quadratic formula if you'd like. I'm not going to do that. Instead, I'm just going to factor out a negative. X squared minus 6x plus 8. And then I'm just going to factor this. So this is going to be the factored form, x and x. Here's a 4 and a 2. And in order for me to get this, it's going to be a negative and a negative. So solving them, this is going to be negative x minus 4 equals 0. And then x minus 2 equals 0. The negative goes away, so I'm just going to be left with x equals 4. And here I'm going to be left with x equals 2. So my x-intercepts is going to be 4, 0 and 2, 0. All right. So now I'm ready to graph after all of that information. So let's start by graphing it. So here is going to be my parabola. The first thing that I know is that it's going to be opening down. Axis of symmetry is at 3. My vertex is at 3, 1. So let's look that up. So here's going to be 3, and here's going to be 1. Okay. I have a y-intercept. My y-intercept is at 0, 8. So at 0, I'm going to go down to 8. 1. Let's say this is 1. Oh, no. So let's say this is going to be my 1. Oh my god. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's at 0. Oh, this should be negative 8. Oh my god. Negative 8. Okay. Okay. So this is going to be negative 8. Okay. And then what is going to be my x-intercepts? It's going to be 4, 0. So here's 4, 0. And then 2, 0. So this is going to look something like this. So it's opening downward, going down to negative 8. And then to 4. Okay. And that is my answer. So just following these steps, it's really easy to just plot them. Okay, now let's solve another problem. Here's my other example. So let's say we want to do write y equals 2x squared plus 4x plus 5 in standard form. And then graph. So that's what we're going to try to do. So we're going to write that in standard form and then graph it. So if you remember, you can see that doing this the way that we've been doing it does take a little bit of a while. And if you have it in standard form, which is this column, it actually might look easier for us to identify the vertex and the x-intercepts and all that other stuff. So let's convert it to standard form. Okay, so we have y equals 2x squared plus 4x plus 5. Let's convert it to standard form. And the way that we convert it to standard form is by completing the square. So first, let's move the 5 over, because we're going to put all of my x's together, and the 5 has nothing to do there. So y minus 5 equals 2x squared plus 4x. Okay, now if you remember, in order for me to complete the square, I need to factor out this 2 because I just need the x squared by itself. So I have y minus 5 is equal to 2x squared plus 2x, and then that's it. Okay, whoops. Alright, and now what I'm going to do, I'm going to complete the square. So I'm going to take the middle term, which is this 2, divided by 2, and then square it, which is going to be 1 squared, which gives me 1. So what I'm going to do is I'm going to add 1 to each side. So right now, watch what's going to happen. I'm going to write it over here. Y minus 5 equals 2x squared plus 2x plus, what am I going to add? I'm going to add a 1. Okay, now if I add a 1 here, I got to add it over here. But notice that if I distribute this 2, there's a 2 outside, so when I distribute this 2, I actually have a 2. So what I'm going to do is I'm going to add a 2, because ironically what I have is 2 times 1, which is a 2. So I have a 2 on the right-hand side. So over here, to compensate that, I have to add a 2, not a 1. So now I'm going to have y minus 3 equals 2, and I can factor this, which is going to be x plus 1 squared. Now I can add this 3 over, and I just have y equals 2x plus 1 whole quantity squared plus 3. Okay, so that's my standard form. So now that I have this in standard form, I can easily figure out what everything else is. So let's figure out, because now we want to graph it. We want to graph this thing. So the first thing that we want to do is orientation. Orientation is going to be my a value. Oops, that's not how you spell orientation. Orientation. Remember, that's going to be my a value. My a value is going to be here. So that's this positive 2. Okay, so that means it's going to be opening up. So it's going to be a happy parabola. The second part that we want to figure out, and after orientation, is axis of symmetry. Axis of symmetry is, for the standard form, is just x equals h. So it's going to be whatever this number is. So let's go back. X equals h. In this case, it's going to be this one. And remember that that part is just going to be the opposite. If it's in the inside, it's going to be the opposite number. So it's going to be negative 1. That's the axis of symmetry. Now for number 3, the next thing that we want to look at is the vertex. The vertex is just going to be these two numbers. So this is going to be negative 1, comma 3. Alright, after the vertex, the next thing that I want to find is my y-intercepts. And the way that I find my y-intercepts, set x equal to 0. So I have y equals 2x plus 1 squared plus 3. Set the x equal to 0. 0 plus 1 squared plus 3. Y equals is going to be 2 times 1 plus 3, which is going to give me 5. So my y-intercept is going to be 0, when x is 0, and then 5. That's my y-intercept. And finally, my x-intercepts. Okay, so to find my x-intercepts, I'm going to set my y equal to 0. So 0 is equal to 2x plus 1 squared plus 3. I'm going to subtract the 3 over. I have negative 3 equals 2x plus 1 squared. Divide by 2, I get negative 3 over 2, x plus 1 squared. And then take the square root. But notice that right when I take the square root, I have a negative under here. I cannot have a negative intercept, so this one there's none. No x-intercepts, because it gives me a complex number. These are going to be imaginary. Okay, so now that I have all of that, I can finally graph my parabola. So, what is this going to look like? So here I have my parabola. Let me move this a little bit down. So I'm going to have my vertex, negative 1, and then 3. 1, 2, 3. Negative 1 and 3. My axis of symmetry is going to be there. Orientation is going to go up. Y-intercept is going to be 0, 5. So 0, 5. So here's 5. Okay. No x-intercepts and just pointing up. Okay. Just going this way. And if you really wanted to plot another point like negative 2, because this is this axis of symmetry right here at x equals negative 1, 1 unit over, here 5, that means that should also be a 5. So just by symmetry. Okay, that's basically all there is to it. We'll do more problems in the next video.